Hello everyone, thank you for joining us today. We are here to discuss the project we have done recently with our client and our partners in Pakistan. So we thought it is a good idea to discuss the project detail with you guys. So basically today Mr. Munib from Greenfield Energy and Mr. Safdar from Beacon Energy are with me. So we will share our point of view on this project, and we will discuss how this project uh, is giving benefit to their clients. And let's move on. So basically, starting from Elum Energy is a monitoring and control company. We have more than 1,000 sites installed with in more than 50 countries. So we are basically expert in monitoring and providing monitoring and control solutions. We have offices in Paris, Casablanca, Cape Town, Sao Paulo, Mumbai, Dubai, Islamabad, Mexico, and Madrid. We have a huge list of clients from all over the world, including Total, Mastar, Scatter, and a lot of other EPC clients from all over the world. So currently, in Elum Energy, our core focus is on three segments, which is power plant, the IPPs. Then we have microgrids, and then we have the commercial and industrial installations. As of now, we are not focusing on the consumer market because we think that our solution is more beneficial towards the bigger plants and towards the microgrids. So we are currently doing projects and equipping the power plants around the world with our hardware. So now I would like to give the mic to my friend Safdar to introduce Beacon Energy.
Hello everyone, this is Safdar from Beacon Energy. I'm working as a National Operations Manager in Beacon Energy right now. Let me introduce you to the Beacon Energy. Beacon Energy is basically a company for a group of from the Beacon House Group. Beacon House Group is basically educational system which is serving Pakistan from last 40 years, and we have like presence in all over Pakistan and also international presence also. So Beacon Energy is basically providing clean energy solutions to its clients. We have like three main offices in Pakistan, Islamabad, Lahore, and Karachi, and we have some regional offices as well, like in Peshawar, in Kasur, and other locations. Till date, we have like installed more than 15 megawatt of C&I projects. We are also providing solutions to our residential clients, and we have a very good reputation in Pakistan. And we have installed more than 3 megawatt, like in different locations of 10 kilowatt, 20 kilowatt. And we are providing services, solutions of grid tie, and also for the backup solutions. We have our own product, our own applications, and we are providing online app services. We have our own app, not providing like some third party. It's our own app. So we have presence in Pakistan. This is all about Beacon Energy.
Okay, so now I would like to ask Munib to introduce Green Fuel.
Hi everybody, my name is Munib Zulfikar. I'm the Chief Operating Officer of Greenfield Energy. I hope you are all doing great. So regarding the Greenfield Energy, we are actually providing the electromechanical services in the PV sector across Pakistan. Majorly, we are doing business in South Punjab, covering all the Punjab and KPK. But we are not limited to all these provinces. We are already doing business in Sindh sector as well. Collectively, in this fiscal year, we have completed more than 10 megawatt of projects. And if I talk about all the collective projects in the recent past, so we have more than 15 megawatt of project as a whole in Greenfield Energy. The services which we are providing mainly Those are fabrication of structure and electromechanical installation to our vendors and clients, and the hybrid genset, as well as the design of the whole system. So the major partner in this PV sector, we are doing business with Beacon Energy, as Mr. Safdar has introduced you before. Other than that, we have some other EPC clients as well, whom we are doing business in Pakistan.
Okay, so let's start with the project. So the project we selected for today, it's basically a beverages factory located in Pakistan. So I think Safdar can introduce the scope of the project.
Yes, this project was awarded to Beacon Energy, and it was an EPC project. As an EPC contractor, we were providing them all the services from on turnkey basis. So first, I would like to introduce the client name. The client name was Hadri Beverages, which is working as a PEPSI Pakistan. And the solar system which we have installed, it was like 852 kilowatt, which is a new system, and they have their own system as well, which was of 142 kilowatt. So the main purpose of this project was to install a new system and also integrate the old system with the new system as well. Basically, the roof type they have there, that was shell roof system, shell roof, and we have installed solar panels over there. They have 5 different locations. 2 were their production halls, 2 were their main offices, and 1 was in this slide you can see that we have a production hall, 2 production halls, which were the main area where we have the shell roofs, and we have installed most of the system, like 600 approximately kilowatt system over there. Rest of the system was installed on the generator and the LT rooms, where there was different type of structures. On the production hall, it was shell type structures, and on the generator room, we have 2 types of structure, L2 and L3. There was previous system which was installed. These were on their offices, Hadri, which was name is Hadri 1 and Hadri 2. And we have integrated all the system in different locations. We have installed the Huawei inverters over there. As you can see that on the Hadri 1 production hall, we have 4 inverters of Huawei 100 KTL, and which was integrated with their LV room. On Hadri 2, there were 2 inverters of Huawei, and on the powerhouse 1, there was 1 Huawei inverter. So cumulative, these were 7 inverters which were installed on different locations and different termination points. The old system was installed on offices, and it was integrated at the LT room side on the generator side. So they have 5 different generators over there, which were synchronized over there with the DeepSea controller. The main criteria was to integrate the solar system with the generators which were synchronized, and also to stop the reverse feed to the grid, because we have 11 kV supply over there. There was a very complete system over there. They have their own MVRs and these kind of equipment installed over there. So we have installed our system and also integrated our system with the existing system to accumulate the overall production. Like the overall system was 1 megawatt, so we have installed it over there.
Okay, so that was the scope of the project. So Munib, if you can explain that how you tackle the client requirement.
Thank you, sir. Thank you, On. This actually, guys, this project deserves to be discussed, as it was quite challenging in terms of integration and communication as well. So regarding the project, there were actually 7 Huawei inverters, which already Mr. Safdar has told you. Those were installed by Greenfuel, and 5 SMA inverters, which were already incorporated in the existing installation. So there were 2 major challenges involved in the communication of these inverters. The first one was that we were collaborating 2 different brands of inverters with Elum controller. One was SMA and the other one was Huawei. So the issue was we were not sure if Elum controller would collab with these two kinds of different brands, but the controller did pretty much good job, and it all goes well. So this issue was rectified on Elum's end. And the second thing, second issue was the distance. That was actually the major parameter and hindrance in the execution of this project. Because as you can see in the slides, there are different inverter shafts scattered across the plant. So if we would have gone with the RS485 twisted pair Cat6 cable, so the minimum distance between these sheds was more than 300 meters. So that this is I'm talking about the minimum distance. Some sheds were even more than that. So these two were the main challenges which we were dealing at this project. So now when there are challenges, there are solutions as well. So in this slide, I will explain you this slide as well. So we had actually two options in rectifying these two problems. The first one was either we would have went for that fiber optic cable, but there was some limitation in that one as well, because it was increasing the value of the project, increasing the budget, so it was not budget friendly for green fuel energy as well as for our worthy client Beacon Energy as well. So there was a smart solution for that as well, and it was to integrate all these inverter in the existing IPs of the facilities of the end client. So Hazri Beverages, they have a vast network of communication LAN across their factory. So we used that existing IPs and collaborated with that IP addresses, respective IP addresses, with the respective inverter sheds. So that's how we did that. You can see this presentation that there are 5 gensets over there, and they were actually they were communicated with each other, or synchronized with DeepSea controller, and over that to at the end to the Elum controller. And on the other hand, there are actually 3 segments of the Huawei inverters. They are actually shown with the inverter shed. So collectively, these were 7 inverters. So again, they were communicated with each other through DAISY chain, and at the end through data loggers into the port of the Elum controller. So all this stuff was done by using the existing IP address of the end client, which at the end of the day saved our budget as well, saved our time as well, because the time was a critical constraint in executing this project. And the third one was that it was done smartly. There was no much modification was done in doing so. And at the end of the day, the controller was pretty good in communicating all these devices, and it's running perfectly at this stage.
Okay, thank you. So basically, if we talk about specifically about the project, as you guys, the gentlemen have explained, that it is a collectively it's a 1 megawatt project with 5 gensets of 400 kV each. So we have 2 types of inverter brands to tackle: 7 inverters from Huawei and 5 from SMA. So basically, the main purpose here was to reduce the fuel consumption of the site by ensuring the solar diesel integration, then ensure the minimum genset loading of 30%, so they can uh, deliver so we can deliver the rest of the power. So this site is also equipped with our ePowerMonitor Pro, so the customer can see online that how the project is working, what they have generated today, yesterday, or in the last month. So basically, specifically, if we talk about the Elum products, our core things are we have multiple use cases. We are compatible with different plant topologies, PV, battery, grid cores, meters, and all these things. We have a very flexible architecture. We work through the interface of TCP RTU, which can fit a lot of technologies in the solar power plant. So we are basically compatible with all the solar inverter brands, the BESS, the meters, sensors, if somehow we are not compatible with any of these brands, we can make a driver for these brands in like no time. So we have very autonomous operations. The configuration is very simple. Our core focus is to make the controller plug and play, so you don't need to know the programming or maybe do the PLCs. So you just need to plug the controllers and follow the instruction, and our team will help you remotely to configure that side. So if we talk about like ePowerControl ST, ST is for solar device integrations. So the key features are single genset minimum loading, curtailment of solar inverters, power to prevent genset from running low load. So basically, we ensure that the genset is loading at the minimum capacity. So grid fade-in management, curtailment of solar inverters, power output to ensure zero export. So it can also uh, work as a zero export for the system. You don't need to install a zero export meter or device separately. Data logging, it is also working as a data logger. It can collect the data and show it on our portal, and it can switch, give you the alarms for the errors and malfunctions. So we have a extended compatibility. The main protocol supported Modbus RTU, TCP, Sunpack, Flavia, Caco, Blue Planet, PMU. Other can be integrated on request, as we already discussed. Local parameter addition, one interface to edit all site equipment parameters, set points, and operating modes. Data export and visualization. So basically, for data export, we used our specially designed ePowerMonitor, which is an online cloud-based application. All the data is transferred from the site to the ePowerMonitor, so you can visualize it on the internet. Then, so basically, as an ePowerMonitor, we have core focus on the ensure performance. It helps operation and maintenance teams to minimize plant downtime. If the plant is underperforming, we can increase uh, the basically output of the plant by uh, using the O&M for the ePowerMonitor Pro, reduce downtime for the plant, increase plant revenues. Then we have easy reporting. If you basically asset manager want to extract a financial report or what they have generated in the last month or last year, they can do it easily. So it's a basically integrated application for the consumer and industrial market. So here we have backup generators, rooftop PV plant, then we have a grid, then we have is integrated all this with ePowerControl ST. Then that ST will shift the data to the ePowerMonitor Pro, so you can see that how your plant is working and you can control it like remotely. Okay. Communication SLD. So basically, ePowerControl ST can work in like lot of configuration. It is one of them. Here we are not using the basically data logger from the inverter manufacturer. So the controller is working as a data logger. We have connected the sensor, PV inverter, genset controllers, AC meters to directly to the ePowerControl. Then that data will be transferred to the ePowerMonitor for the monitoring purpose. So in the second configuration, the ePowerControl ST can also be integrated with the data logger as well. If you have a site where you have installed maybe let's say SunGrow or a Huawei data logger, you can also use a ePowerControl ST in that site as well. Okay, guys, so that brings us to the end of the session. So now we will take the few questions from our audience. So if we are unable to answer any question, then you can reach us directly on our email addresses. Safdar, mine, and Monib, our email addresses are shown here. So you can send us an email, and we are happy to help you. So let's take some questions. Okay. So basically, first question is related to the price. Umar have asked that what is the price of a single genset controller? So I think Monib, you can answer that. You are the best person to ask this question.
Well, thank you, Umar. Actually, the thing is, I'm at the end of the chain in this PV market, so definitely I'm the right person to answer you this question. Look, Umar, the first thing, the first factor in deciding the price of the controller is actually what you are asking for. Is it you are asking for a single genset solution or a dual genset solution? So the price slightly varies with that. So for further clarification, you have my email address, so you can just put your query through it, and I'll just give you a best proposal for that. Because right now in the market, we are giving the best optimized prices as compared to our competitors.
Okay, thank you. So okay, let's take another one. So basically, this question, I think we already addressed this in the presentation, but again, why special wiring is not used for the project? I think, Munib, you can again answer that as well. Why didn't you use the special wiring for the project?
So actually, as I have already explained in those slides, this project, there were certain challenges in executing that project. The system was scattered far apart in the whole plant. Actually, if the inverters were on a single location, then we would have easily done with that. But as you would have seen in the slides that there were 7 different inverters of Huawei and 5 of SMA, and they were not present at the same location. They were scattered on different locations, different corners of the plant, and minimum distance between them was more than 300 meters. So we would have only one solution going with the fiber optics, but we would have to do the excavation, underground trenching. We would have to cope with the price of the fiber optics because it's too much costly. So at the end of the day, I have to facilitate my clients. So there was a price factor affecting directly to my client. So he asked for a smart solution, and we gave them. If we have a smart solution by reducing the price, so we will opt for that. So there was an existing facility of IP, so we utilized that.
Okay. Okay, so we have another question from Ahmed. So basically, I think the question is that how beneficial is the solar diesel integration for the C&I market? I think so. Safdar, you can answer that.
Yes, the question was regarding the benefit of this system for CNI. You can see that they have like different loads in different areas. As we can look in that case, the customer have a load of more than 5 megawatt, which is a continuous load. We are only producing 1 megawatt, but you can see that it is reducing a bill of 1 megawatt for them. And they have also like peak season and off peak seasons. So in the off peak season, when they have no utilization, they can produce and sell to the national grid. So this was the main purpose of that project also.
Okay, so basically we want to like make the plant financially viable. So when in the off season the factory is not working, so still you can generate the power and sell it to the national grid. Okay, so and we have another question that did we we have integrated the reactive power control for this plant?
No, currently for this plant, we didn't have the reactive power control as it was not required. You can see that their utilization was more than the generation. So on that part, there was no requirement from the client also, and also in the design part, it was not included. But yes, Elum have the reactive power control devices and they can control it. For future projects, we will be like looking into that also.
Yeah. But basically, the controller can do the reactive power control, but it was not required in this project. But we can do that. That's not an issue. So basically, guys, that's all for today. Thank you again for joining us. Thank you, Saptar. Thank you, Muneeb. So
You're welcome.
if you guys have any questions to me, to Saptar, to Muneeb, you can just send an email, and we are happy to help you.